We developed a system called Badgerfeet. Badgerfeet is a virtual try-on system that we have built upon the network architecture idea introduced by CP-V10. CP-V10 is a publication that is published in ECZV 2018, so it is a really recent work. Virtual try-on essentially is a kind of computer vision technique that synthesizes photorealistic image from an image of a human model and an image of clothes. As online shopping becomes popular in the current pandemic, virtual try-on technology is actually really important and useful because customers will now be able to envision themselves wearing a particular t-shirt without actually going into a fitting room with this shirt physically. So they will be able to see, they will be able to use the computer monitor as a kind of mirror that they see themselves wearing a shirt that they were probably going to purchase.
Now let's look at our demo. First, you need to select an image for a model, and then it will generate the key points with OpenPose and the image segmentation with libjppnet. And this will take a while because we're using a free serverless Cloud Run. And for the clothes image, you'll need to upload a transparent PNG. If you need background remove, you can use this link. And this will generate a mask. Let's wait for this to finish. Okay, now you can click try on to see the fitting with CP-V10. And this will generate a warped cloth and a mask that will fit onto the model. And then let's try to use different clothes. So the previous images and clothes are from the same dataset CP-V10 used. Let's look at some images we gathered from the internet and see how it performs. As you can see, sometimes the result is not so good. This one looks better. Let's change another model image we got from the internet.
Okay, so I'm going to introduce the CP-V10 which we use as our model to generate the final virtual try-on result. And first we need to train the model, and we use the original dataset provided by CP-V10. And also we try to use the same preprocess tool such as OpenPose and the libjppnet. OpenPose is for generate the key point, and libjppnet is for generate the image segmentation. And since we want to use our own dataset, so we need to know how to preprocess our own dataset. And here's the methodology about CP-V10. Basically, CP-V10 has two stages. First stage is the GMM model, which is the geometric measurement module. And the second stage is the try-on module. So inside the CP-V10, the GMM model will first use the person representation and the clothes as input, and then go through whole model. It will generate the warped clothes, and we will use this warped clothes as an input for our town model. And after this network, we will generate the composition mask and the random person. And finally, we will use composition mask to combine with the warped clothes and the random person to generate the final result. And this is how the CP-V10 works.